This video is going to cover Section 3.1, Day 2, and we're going to be talking about derivatives and their graphs. And specifically, if you look at the back cover of the packet that has all the learning targets, for today we're going to be focused on the target that's labeled DA, so Derivative Applications.A. And really we're going to be focusing on the target I can match a function. Actually, I can match a function's graph with its derivative. So today we're going to be focusing just looking at the graphs, and based on properties of the graphs, we're going to see if there's a way that without knowing anything about the equation or its exact derivative, if we can sketch a graph of that derivative. So before we start looking at the derivatives, you can see on this page, the top we have a graph. That's the graph of f of x. Okay, and here we have a sine curve. I'm going to scratch off this 10 and just make this from 1 to -1, as now it matches the bottom graph, which you can see is the graph of f prime of x. So we've been given both of these graphs, and really what our goal is for today is to be able to figure out how do we get the graph of the derivative if we just have a graph of the function itself. So we're going to look at some of the behaviors of this function first. We're not even going to think about the derivative quite yet, and we're going to talk about some of the properties. So the first points I'm going to make note of are our max and min points. And I'm going to use a green pen. You may at this point want to pause it and get some colors. It'll be extremely helpful when we're doing this work if you can use colors to kind of color code your work. So I'm going to use a green pen, and I'm going to mark points at my maximum value. And I'm going to mark a point at my min down here. Okay. And what I want us to think about is if I were to look at a tangent line at these max and mins, right, and I'm just going to sketch one in. Hopefully it's pretty easy to see that at that point, the slope of the tangent's 0, and that's going to be important here pretty soon. So I'm going to say at the max, the slope of my tangent is equal to 0. And the same is going to be true down at my min. The slope of my tangent is equal to 0. So I know in my graph I have max and min points at those values. And I'm actually going to make a little table here so I stay organized. So I'm going to write down some information about this graph. So here's f of x, and so far what we know is we have a min and max, okay, at these green points. Okay. So now I'm going to look at the behavior, some other behaviors of the function. And so I'm going to look over this interval here that I'm going to kind of code in orange. And I notice that on this portion of the graph here, that I'm going to trace out, my curve is increasing. I'll write this in black. So I'm increasing, or in other words, I have a positive slope on that interval. And if I'm looking, I can also note that on this interval here, I also am increasing or have a positive slope. So I'm just tracing over that pretty heavy so that you can see that. So again, I'm increasing. Okay, which also means that I have a positive slope. And then the rest of my curve in between my max and min values, obviously along that interval, I'm just going to trace over this in yellow. Right, we notice that we're decreasing along that whole interval. So I'm decreasing, which means I have a negative slope. Okay, so that's just some basic behavior describing my graph. And so I'm going to add to my table here where I'm increasing. I'm going to just abbreviate that, where I have a positive slope. That's where I've highlighted in orange. And then I'm going to make note of where I am decreasing and have a negative slope. So that's nothing new there. I think that's some vocabulary that hopefully we're pretty familiar with. And my negative slope is coded in yellow. So now we want to see if we can draw some connections between the behavior of my function, and I'm going to zoom out here now so that we can see the graph of f of x along with the graph of f prime of x. And so it looks like I'll just kind of be able to squeeze that in here. And so now in my table, I'm going to add f prime of x. And we're going to see if we can correlate the behavior of that function with the behavior of its derivative. So the first points that I want to kind of focus in on, and actually I want to focus this, see if I can get a little better. That's a little better, are the zeros of f of x. So I'm going to use my ruler, and I'm going to look at where that 0 is on my function, and I'm going to kind of trace down here. And it looks like for this max value, that corresponds to a 0 on the graph of my derivative, on f prime of x. And so I'm going to see if the same holds true of my min value. And you can see pretty quickly that it does. So if I draw a line through here, I notice the same thing. My min value corresponds to a 0 of the derivative. So that's the first connection we want to make. The mins and max on my derivative of f of x correspond to the zeros of my derivative. So that helps our derivative to start and take shape. So now I'm going to see what I notice about the intervals where I have an increasing interval with a positive slope and decreasing with the negative slope. So if I look over my interval where I have a positive slope, down here over the same interval I'm going to highlight it orange. And what I notice is over that same interval where I'm increasing, right, and same over here, here's where I'm increasing. What I notice is that whenever my function is increasing or has a positive slope, its derivative is above the x-axis. So again, where my function is increasing over that same interval, my derivative is above the x-axis. So I'm going to make a note of that here. It's above the x-axis. Likewise, if I scoot this up a bit, over the interval where my function is decreasing or has a negative slope, my derivative lies below the x-axis. And so I'm going to add that to my chart as well. Wherever my function is decreasing or has a negative slope, my derivative over that same interval is below the x-axis. And these are the major points that I want you to realize at this point. That behavior of f of x is directly related to the behavior of its derivative. So again, wherever I have a min or a max on the derivative of my function, those correspond to the zeros of my derivative. Wherever my function is increasing, my derivative over those same intervals lies above the x-axis. And finally, wherever I am decreasing, my function lies below the x-axis. And so we're going to use those properties now to be able to match the graph of a function with the graph of its derivative. Okay, so we're going to look next on page 5 and try to do some matching using the same ideas. And I'll keep the same colors so we can be somewhat consistent here. So I'm going to move this back down so I can get zoomed in a little better. And we're going to look at number 2 here. So here they're giving me the graph of f of x, and I have to decide which of these graphs would best approximate the graph of the derivative. Again, this notation f prime of x is just denoting the derivative. Okay, and I'm going to make some little notes as reminders to myself that I can reference while I'm going through these problems. So we said on the previous page that wherever I encounter a max or a min of f of x, that corresponds to the zeros of f prime of x. Wherever I have a positive slope, or where f of x has a positive slope, that means f prime of x is above the x-axis. And finally, wherever f of x has a negative slope, f prime of x is below the x-axis. Okay, and this should make sense. We know that f prime of x represents the slope of that tangent. So it makes sense that if I have a positive slope along an interval, my derivative, which represents that slope, should be positive or above the x-axis. So let's go ahead. Again, I'm going to use those same colors here. And so if I'm looking at number 2, I can quickly pick out a min value here and a maximum value just before 1 there. So the first thing that I do when I approach these matching problems is I see if there's any that I can rule out, any possible graphs of the derivative that I can rule out. And so I'm looking for a graph right now. Based on what I see here, I'm looking for a graph that has a 0 at -2 and about 1. So I'm going to look at my choices, and I see that this has a 0 at -2 and a 0 at 1. So I can't quite eliminate that choice yet. So I'm going to keep going. If I look here, I also have a 0 at -2 and a 0 at 1. So again, can't quite eliminate that choice. Over here, I have zeros at -1. This only has 1 0, and I know I'm looking for 2, so I can go ahead right away and eliminate that choice. And then finally, I look at my last choice. I have a 0 at -2, which is what I'm expecting, and somewhere around 1. So again, I'm going to keep that option for now. So we've been able at least to eliminate one choice by looking at those zeros. So now I'm going to pay attention here to the slope of my graph of f of x. So I know that in between those two zeros, this has a positive slope. So that tells me on the graph of my derivative, and I'm going to make a note here, I have a positive slope in between those two zeros. So that tells me the derivative should be above the x-axis between about -2 and 1. So of the choices that I've got left, I need to find a graph where the graph is above the x-axis between those zeros. So I go back to my choices now. So between -2 and 1, this graph is above the x-axis. So again, that's a graph that I keep. Here I'm also going to look, and between -2 and 1, and maybe I'll mark those in green again, I'm also above the x-axis, so I keep that as an option. Now on my last one, even though my zeros were in about the right place, I can see that in this graph, I'm actually below the x-axis over that interval. So I'm able to eliminate that option, or that graph as an option. So now I'm down to 2. And so now I look at the other behavior here. And I can see here, to the left of -1, I am strictly decreasing. So to the left of -1, I should always be below the x-axis. And then over here, it looks like I'm below the x-axis for a bit, and then maybe I have a slight turn up here, so I go back above. So let's focus on this here. We said to the left of -2, I should be below the x-axis because I'm strictly decreasing there. So if I go back to my option here, it looks like I can rule out this choice, because even though I'm below for a little bit, I do go above the x-axis, which we said should not be the case. So now I can eliminate this, and I find that I match my behavior here. I'm below the x-axis here and over this interval, and then between those two zeros, I lie above the x-axis. So that second graph is the match of the derivative. So again, I kind of use a process of elimination approach to this when I'm working through these. So these last few minutes here, we'll go through a few more of these examples, and then maybe we'll go through 1 through 3 in the video, and then maybe we'll use 4 through 6 to just discuss quickly when we start class. So let's go ahead and we'll look at number 1. Again, my approach is I always first start by identifying the mins or maxes of my function, and then try to find a derivative that has a 0 at that point. So for number 1, I'm looking for a function that has a 0 at x equals 0. And so if I quickly scan over my choices, right, this has a 0 at -3. This has 2 zeros, which I know I'm not looking for. C seems to be a good candidate because it has a 0 at 0. And it looks like none of these are really good options. So let's see if C matches what we would expect from that behavior. So if I go back to my original graph, I notice I'm decreasing from -infinity to 0, which means I would expect to be below the x-axis over that interval, which I am. Okay. Similarly, I notice I'm increasing from 0 to infinity, and accordingly, I'm above the x-axis over that same interval. So I know that 1 matches with choice C. And number 2, again, same thing. I'm going to locate, my max and min values. Disregard that point. My max and min values, so at -1 and 1, I'm looking for a function down here that has zeros at -1 and 1. And it looks like this is going to be my only option. There's my zeros at -1 and 1. I'm increasing between those zeros, which means I would expect to be above the x-axis between those zeros, which matches this behavior. I'm decreasing on my other intervals from -infinity to -1 and 1 to infinity. which corresponds with me being below the x-axis here. So F is the match for number 2. Okay, then the last one we'll do for today. Here I find that I have a min value at, looks like -1 to -3. So again, I'm scanning my choices, and the first thing I'm looking for is which graph down here has a 0 at -3. And my only option is here. But again, just for the exercise and the practice, we'll verify. My graph of f of x is increasing from -3 to infinity, which means I would expect it to be above the x-axis over that interval. And luckily enough, that matches that behavior, where I am decreasing on f of x from -infinity to -3. I find that I am below the x-axis on the graph of my derivative. So I match with graph A. So we'll leave it there for this video. Tomorrow when we come into class, we'll go through 4 through 6 to make sure we've all got the idea, and then you'll be working on an activity to practice with this.